Dear students, today we will discuss the questions of Grand Test 2. Let's look at the first question. Let A is equal to 1, 2, 3. Then the number of relations containing 1, 2 and 1, 3 which are reflexive and symmetric but not transitive. The set A consists of 3 elements 1, 2, 3. I want to find a relation which consists of, I want to say how many relations are there, which consists of these 2 elements. 1, 2 and 1, 3, these should be present in that relation, and this relation should be reflexive and symmetric but not transitive. Okay. So first of all, I want to make it as reflexive. What can I write? I can add 1, 1, I have to add these 3, 1, 1, 2, 2 and 3. Okay. After that, I want to make it symmetric. Symmetric, 1, 2 is there, so I will write 2, 1. 1, 3 is there, immediately I will write 3, 1. Okay. Now look at this relation. This relation is reflexive, yes. It is symmetric, yes. Then is it transitive? 1, 2 is present, 2, 1 is present, 1, 1 is there. Okay. But 2, 1 belongs to R, 1, 3 belongs to R, which will imply that 2, 3, but 2, 3 does not belong to R. Hence, this relation is non-transitive. This is what we want. We want a relation which is reflexive and symmetric but not transitive. This is one such relation. Then, let us say, can we find any other relation? So, which consists of 1, 2 and 1, 3, and it should be reflexive and symmetric. So, I have to add all these elements. So, I have to add these elements. Then, something else I should add. So, if I write, let us say, if I write 2, 3, then since it is symmetric, I have to write 3, 2 also. Okay? Since I want a relation which is symmetric also, so I have to include 3, 2 also. Now, just check. This is reflexive, symmetric, and is it transitive or not? That we want to check. 1, 2 present, 2, 3 is present, 1, 3 also present. Just observe that this relation is nothing but A cross A. This has 9 elements, A has 3 elements, so A cross A has 9 elements. This is nothing but the universal relation. As we know, a universal relation is always an equivalence relation, which means this is transitive also. But what we want? We don't want it to be transitive. So, this is the only relation which is reflexive and symmetric but not transitive, containing these 2 elements. Okay? So, the answer is 1. First option. Then, number of binary operations on the set AB. Number of binary operations on this set. So, number of binary operations on a set consisting of n elements is n to the power n square. This formula you know. So, now this here in this case n is equal to 2. There are 2 elements in this set. So, the answer is 2 power 2 square, which means 2 power 4, that's equal to 16. This formula you should remember. The number of binary operations which can be defined on a set with the n elements is n power n square. Next, third question. In a class of 60 students, 25 students play cricket and 20 students play tennis. 10 students play both the games. Then the number of students who play neither is. Okay, let us solve this problem through a Venn diagram. Let me consider this as the set of all students in the class as the universal set. There are 60 students in this class. Then let this represent the students, there are students who play cricket, and let it represent the students who play tennis. Okay? So this region, which is the intersection of these two, is the students who are playing both the games. So how many are there? 10 students who play both the games, that 10 I will write here. And how many play cricket? 25 students play cricket. In that 10 I have written here, the remaining is 50. Then, how many play tennis? 20 students play tennis. Among 20, 10 are here. The other 10 are right here. So, altogether, the total number of students who play either of these 2 games or both the games are 15 plus 10 plus 10. That is 35. Okay? But total number of students is 65, right? So, 65 minus 35, that's equal to 25. So, 25 will be here. These are the ones, they are the students of this class but who do not play any of these 2 games. Hence, the answer is 25. Second option. Let's look at fourth question. A real value of x satisfies the equation 3 minus 4ix by 3 plus 4ix is equal to alpha minus I beta, where alpha and beta are real numbers, if alpha square plus beta square is equal to 1. Okay. So what they are doing is alpha minus I beta is equal to 3 minus 4ix divided by 3 plus 4ix. We are asked to find out alpha square plus beta square. So what I do is I find out alpha plus I beta. Here in the equation we have alpha minus I beta is equal to 3 minus 4ix by 3 plus 4ix. I want alpha plus I beta. So what do? I will replace I with minus I. Okay, wherever there is I will replace it with minus I. That will give us 3 plus 4ix divided by 3 minus 4ix. We want to find out alpha square plus beta square. We know alpha plus I beta and we also know what is alpha minus I beta. So I will multiply these two equations. If I multiply these two equations, alpha minus I beta into alpha plus I beta, that's equal to this product will become 1. These two gets cancelled. Alpha minus I beta into alpha plus I beta will give you alpha square plus beta square. So alpha square plus beta square, that's equal to 1. First option. Look at question number 51. Question number 5. The total number of terms in the expansion of x plus a whole power 100 plus x minus a whole power 100. X plus a whole power 100 plus x minus a whole power 100. If I expand this expansion contains 101 terms. This expansion also contains 101 terms. If I add them, we get 202 terms. No, that's not correct, because if I expand this, there are 101 terms. There are 50 terms with odd coefficients. Right? So if I expand it, the first term will be 100 c0 x power 100 into a power 0 plus 100 c1 x power 99 into a power 1, etc. Here if I expand, I am going to get 100 c0 into x power 100 minus 100 c1 into x power 99 into a. Here alternate terms will be positive and negative. The odd coefficients will have negative term here. So when we add them up, those gets cancelled. I mean the terms containing 100 c1, 100 c3, 100 c5, etc. Here 100 c99, all those gets cancelled. 50 of those terms gets cancelled. And 51 will be remaining here, 51 will be remaining here, but those will be similar. These 51 are similar to these 51, like 100 c0 x power 100 plus 100 c2 x power 98, etc. So when I add them, it will be 2 into 100 c0 x power 100 plus 100 c2 x power 98, etc. So the number of terms after all the simplification is 51. 51, third option. Then sixth question. In a GP of positive terms, if any term is equal to the sum of the next two terms, then the common ratio of this GP is. Any term is equal to the sum of the next two terms. Any term. So I will take A. Sum of the next two terms. A is the first term. I am considering a GP with first term as A and common ratio as R. So first term is A, second term is AR, then AR square, AR cube, etc. So here it says that any term is equal to the sum of the next two terms. So first term is equal to sum of second and third. Sum of second and third means AR plus AR square. I will divide this equation by A, that will give you 1 is equal to R plus R square, or R square plus R minus 1 is equal to 0. Now R is equal to, I will use formula for quadratic equation, minus B plus or minus root of B square minus 4AC divided by 2A. So given that it is a positive GP, in a GP of positive terms, so R must be positive, hence I will take plus here, with minus 1 plus root 5 by 2. This is the answer. But options contain sin 18 degree and cos 18 degree. As you know, sin 18 degree, do you know? Sin 18 degree is equal to root 5 minus 1 by 4. Okay? So here we have root 5 minus 1 by 2. So I will do it like this. R is equal to 2 into root 5 minus 1 by 4. Right? So multiply and dividing by 2. So this root 5 minus 1 by 4 can be written as sin 18 degree. So R is equal to 2 sin 18 degree. 2 sin 18 degree, which is the fourth option. Okay, that value you must know. Then the contrapositive of P or Q implies R is contrapositive, converse, inverse, contrapositive. Okay, so if P implies Q, this is a given conditional, then converse is given by Q implies inverse is given by negation P implies negation Q, and contrapositive is given by negation Q implies negation P. This you must remember. Among these three, one question is a definite question. P implies Q. If P implies Q is the given conditional, its contrapositive is given by negation Q implies negation P. Now what they have given? They have given P or Q implies R. So its contrapositive will be of this form, that is negation R implies negation of P or Q. Here we have this option, third option, so you can directly write that answer. Or in some cases it may be simplified also. After simplification, this will become negation P and negation Q. This option may be present and then this will be the right answer. Okay, let's go to the next question. 8th question. The length of the lattice rectum of the ellipse 3x square plus y square equal to 12. I'll divide by 12. We have this equation 3x square plus y square is equal to 12. When I divide by 12, we are going to get x square by 4 plus y square by 12 is equal to 1. Here you observe that A is less than B. The major axis is along y axis. This ellipse is of this form. Okay, major axis is along x axis, along y axis. Minor axis is along x axis. Okay. In general, for a standard ellipse, the length of the lattice rectum is given by 2b square by a. For a standard ellipse. A standard ellipse means an ellipse with the center at origin, major axis along x axis and minor axis along y axis. Now here we are talking about an ellipse with the center at origin, major axis along y axis and minor axis along x axis. For this ellipse, the formula is 2a square by b. 2a square by b, that means 2 into 4 by b. b is root 12, b square is 12. Root 12 can be written as 4 into 3, 2 root 3, 2 gets cancelled. So the answer is 4 by root 3, which is the fourth option. Then, 9th question. If tan theta is equal to a by b, then b cos 2 theta plus a sin 2 theta is tan theta. They have given tan theta as a by b. We are asked to find out b cos 2 theta plus a sin 2 theta. Okay. So we can write the sin 2 theta and cos 2 theta in terms of tan theta. You know this formula. Cos 2 theta can be written as 1 minus tan square theta divided by 1 plus tan square theta. And sin 2 theta can be written as 2 tan theta divided by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta. Now in place of tan theta, I will substitute a by b. b into 1 minus tan square theta, that will become a square by b square divided by 1 plus a square by b square plus a into 2 tan theta, that is 2a by b divided by 1 plus a square by b square. Okay, so b into, I will take LCM here, b square is the LCM, b square minus a square divided by b square. Here in the denominator, we get b square plus a square by b square, that b square gets cancelled. So you will have b square minus a square divided by b square plus a square plus a into, here if I take LCM, b square plus a square by b square, one of those b gets cancelled, other b will come up, 2ab divided by b square plus a square. There is a common denominator in b square plus a square. We just need to simplify this numerator. Numerator will become b cube minus a square b plus 2a square b. That's equal to b cube minus a square b plus 2a square b, that will give you plus a square b divided by b square plus a square. That's equal to, take b as a common factor, b into, this will become b square plus a square divided by b square plus a square. These two gets cancelled, hence we get b as the answer, which is the second option. Okay, then 10th question. The number of non-bijective mappings possible from A to B is number of non-bijective mappings. Actually, there is no formula for number of bijective functions. Sorry, number of non-bijective functions. We have a formula for number of bijective functions. What we do here is, first we will find out the total number of bijective functions that can be defined from A to B, and then find the total number of functions. Total number of functions minus the number of bijective functions will give us the number of non-bijective functions. Okay. So here, how many bijective functions? We can define a bijective function from A to B, provided number of elements in A must be equal to number of elements in B. If n of A is equal to n of B is equal to n, then the number of bijective functions that can be defined from A to B is n factorial. Here number of elements in A is different from the number of elements in B, so we cannot find, there does not exist any bijective functions. Hence, all functions that are defined from A to B are non-bijective functions. How many functions can be defined from A to B? We know the formula, n of B to the power n of A. In this case, n of B is 2, n of A is 3, 2 cube is 8. So the number of non-bijective functions are 8. 11th question. Let f from 2 to infinity to r be the function defined by f of x equal to x square minus 4x plus 5. Then the range of f is f of x is equal to x square minus 4x plus 5. We have to find its range. So x square minus 4x plus 4 plus 1. I can write this as x minus 2 whole square plus 1. X square minus 4x plus 4 can be written as x minus 2 whole square plus 1. This is our f of x, right? So I can write x minus 2 whole square. This is always greater than or equal to 0, right? Add 1 to this inequality, we get x minus 2 whole square plus 1 is greater than or equal to 1. So f of x is always greater than or equal to 1, and obviously less than infinity. So the range is 1 to infinity, close to infinity, second option. Then sin inverse of root 3 by 2 minus tan inverse of minus root 3. Sin inverse of root 3 by 2, obviously we know that it is pi by 3. Tan inverse of minus root 3 is minus pi by 3. Minus of minus pi by 3 to become plus pi by 3. Pi by 3 plus pi by 3 is equal to 2 pi by 3, second option. Then, if cos inverse x plus cos inverse y plus cos inverse z is equal to pi, then what happens? Okay. So here, better you can go for some substitution. Put some value for x, y, z such that this equation will hold good. I will take each of them as pi by 3. That means I will take x equal to y equal to z is equal to 1 by 2. Okay? So this is trial and error I am doing. I am taking x as 1 by 2, y as 1 by 2 and z as 1 by 2. Then cos inverse 1 by 2 is pi by 3. Pi by 3 plus pi by 3 plus pi by 3 will give us pi. Okay. So now I will substitute in the options and check what happens. First option, if I substitute, I am getting 1 by 4 plus 1 by 4 plus 1 by 4. That's equal to 3 by 4. On LHS we are getting 3 by 4. Whereas on RHS we are getting 2 into 1 by 2 into 1 by 2 into 1 by 2. That will give you 1 by 4. LHS is 3 by 4 and RHS is 1 by 4. So first option ruled out. Look at second option. In the second option, if I put x, y, z as 1 by 2, 1 by 2, 1 by 2, we are getting 1 by 4 plus 1 by 4 plus 1 by 4 plus 2 into 1 by 2 into 1 by 2 into 1 by 2. Okay? So this is 3 by 4 plus here 1 by 4, which is 4 by 4, 1. But what we have on RHS is 0. So second option rolled out. First option already implemented. Look at third. What is the difference between second option and third option? Of course, that is second and this is third. Other than that, LHS is same for second option and third option. Only there is a difference in RHS. Here it is 0 and here it is 1. So, whatever we have seen here, we are getting 1. So, it holds good. So, third option may be the answer. See, unless you know that fourth is not correct, you cannot say third is the correct answer. We can only say that third option may be correct. Look at fourth now. There if I substitute x, y, z as 1 by 2, 1 by 2, 1 by 2, 1 by 2 into 1 by 2, that will give you 1 by 4 plus 1 by 4 plus 1 by 4. This is LHS, that will give you 3 by 4. Whereas on RHS you have 1 by 2 into 1 by 2 into 1 by 2, that will give you 1 by 8. So fourth option also not correct. Only one option which is correct now is the third option. Okay, 14th question. If A and B are two square matrices of the same order and AB is equal to A, BA is equal to B, then what happens? AB is equal to A and BA is equal to B. I will multiply this equation by A. Multiplying by A from the right side. Okay. So AB into A is equal to A into A unit x square. Since matrix multiplication is associative, AB into A can be written as A into BA. That's equal to x square. What is BA? From that equation, BA I write as A. AB is equal to A square. What is A? A. So A is equal to A square, which means A square is equal to A. In the same way, we can prove that B square is equal to B. So second option is the right answer. Then 15th question. If A is equal to this matrix, then what is determinant of A inverse they are asking? You know this formula, determinant of A inverse is nothing but the determinant of A whole power minus 1. In other words, 1 by determinant of A. Okay. So let me find out what is determinant of A. Determinant of minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. That's equal to minus 1 into 1 minus 1, 0, minus 1 into minus 1, that will give you minus 2, plus 1 into 1 plus 1, that's 2, we get 2 plus 2, 4. Determinant of A is equal to 4, therefore determinant of A inverse is equal to 1 by 4, which is the fourth option. Then 16th question. If the value of a third order determinant is 60, okay, let me call that as A. Determinant of A is equal to 60. Okay. Then the value of the determinant formed by replacing each of its elements by its cofactors is. Say, let me take A is equal to a third order determinant matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is the matrix A. Its determinant is 60 they have given. Now we are asked to find the determinant of a matrix. We are asked to find the determinant which is formed by the cofactors. Okay, so cofactors of this, I will write cofactor matrix. Okay, cofactor matrix, that is equal to, I will represent it by capital letters. A11, A12, A13, A21, A22, A23, A31, A32, A33. We are asked to find the determinant of this matrix. Okay. Now, from this matrix only we get adjoint. Adjoint of A is the transpose of the cofactor matrix, right? By taking the transpose of this, we get adjoint. And therefore, the determinant of adjoint of A is same as the determinant of a cofactor matrix, because you know that in a determinant, if you interchange rows with columns, so there is no change in the value of the determinant, right? So, determinant of the cofactor matrix is same as the determinant of adjoint. So, actually in this question, what they have asked is to find the determinant of adjoint of A. Okay. For this we know one formula. Determinant of adjoint of A is equal to determinant of A power n minus 1, where n is the order of that matrix. This is a formula you must know. So determinant of A is 16, n is 3. It's a third order determinant they have given. N is 3. 3 minus 1 is 2. 16 square is 256. Third option. Then look at this determinant. This value we have to find out. 0, p minus q, p minus r, q minus p, 0, etc. You just observe the diagonal elements are zeros. And non-diagonal elements you just check. Here we have p minus q, here q minus p, p minus r minus p, q minus r minus p. They are the negative of each other. So that means this is the determinant of a skew symmetric matrix. Determinant of a skew symmetric matrix of odd order is 0. This is a determinant of skew symmetric matrix of third order. So you know the formula. Determinant of a, or if you don't know, remember this formula. Determinant of a skew symmetric matrix of odd order is 0 and of even order is a perfect square. Remember this result. Determinant of a skew symmetric matrix of odd order is 0 and of even order is a perfect square. So here 0 is the answer, first option. Then look at question number 18. If cos alpha minus sin alpha cos alpha, it's printed as a should read as alpha. Then a plus a dash is equal to I if the value of alpha is. So they have given that a plus a dash is equal to I. The given matrix A is cos alpha minus sin alpha cos alpha. Okay, this is A. Given that a plus a dash is equal to I, from this I can write what is a dash. A dash is just take the transpose of this. You get cos alpha, sin alpha, minus sin alpha, and cos alpha. Okay? So a plus a dash is equal to I. Add these. When I add them, I am getting 2 cos alpha, 0, 0, 2 cos alpha is equal to I, the identity matrix 1, 0, 0, 1. Okay? Equate these two. We get 2 cos alpha is equal to 1. So cos alpha is equal to 1 by 2. Cos alpha is equal to 1 by 2, means alpha is equal to pi by 3, 60 degree. Pi by 3. Second option is the correct answer. Then 19th question. If f of x is equal to 1 minus root 2 sin x by pi minus 4x, if x not equal to pi by 4, and it is a if x is equal to pi by 4, is continuous at x equal to pi by 4, then what is a? See, the function is defined as f of x is equal to 1 minus root 2 sin x divided by pi minus 4x. If x not equal to pi by 4 and a if x is equal to pi by 4. This function is continuous at x equal to pi by 4. Then what is the value of a? It is continuous at x equal to pi by 4 means limit extends to pi by 4 f of x is equal to f of pi by 4. By definition, limit extends to pi by 4 f of x is equal to f of pi by 4. Okay? Now, in place of f of x, I will substitute this 1 minus root 2 sin x divided by pi minus 4x. F of pi by 4 is here. If I directly apply the limit, we are getting sin pi by 4 here. Sin pi by 4 value is 1 by root 2. Root 2 gets cancelled. 1 minus 1 is 0. Here 4 into pi by 4, 4 gets cancelled, pi minus pi 0. So this is of the form 0 by 0. If it is of the form 0 by 0, we can go for L'Hospital's rule. So using L'Hospital's rule, that means if we differentiate it, we get minus root 2 cos x divided by minus 4. Now apply the limit as x tends to pi by 4. Cos pi by 4, that is 1 by root 2. Root 2 gets cancelled. So the answer is 1 by 4. Fourth option. Then 20th question. Limit extends to 0. 1 minus cos x divided by x into log 1 plus x. X into log 1 plus x. Here I will multiply and divide by x in the denominator. I'll divide by x here and multiply by x, so it has become x square. Why did I do so? Because I know one formula which says that limit x tends to 0 log 1 plus x divided by x is equal to 1. And I have log 1 plus x here, so I wanted x in the denominator. So as x approaches 0, this will become 1. Then we are left with the limit x tends to 0, 1 minus cos x by x square, whose value is equal to 1 by 2, standard result. Okay? If you know, well and good. If you don't know, not an issue. You use L'Hospital's rule, it will become sin x by 2x when I differentiate it. This is what I get. And as x approaches 0, sin x by x is equal to 1. So the answer is 1 by 2. In this way also you get the right it. Or else I advise you to remember this formula, limit x tends to 0, 1 minus cos x by x square equal to 1 by 2. So 1 by 2 is the answer, which is the fourth option. Then look at question 21. If the function f of x is satisfied, limit x tends to 1, f of x minus 2 by x square minus 1 is equal to pi. Then limit x tends to 1, f of x is equal to, okay, limit x tends to 1, f of x minus 2 divided by x square minus 1 is equal to pi. This is equal to pi. Now if I directly apply the limit as x tends to 1, see, don't write f of 1 because we don't know whether f of x is continuous or not. If f of x is continuous at x equal to 1, then only we can write limit x tends to 1, f of x is equal to f of 1. As of now, I don't know because in the question they have not mentioned that whether it is continuous or not. Okay. So if I directly apply the limit, I am going to get like this. Limit x tends to 1, f of x minus 2, because for this if I apply the limit, it will remain as 2 only. So denominator will be 1 minus 1, that is here. Okay. Now, if this numerator is positive, then this expression will tend to plus infinity. If this numerator is negative, then this expression will tend to minus infinity. Okay? So the value of this will be either plus infinity or minus infinity, depending on whether this numerator is positive or negative. But on RHS, what they have given? This limit value is equal to pi. Then pi is a real number, right? So it is of course much lesser than infinity. So this will tend to plus infinity or minus infinity. But here they have given that as pi. Therefore, this cannot be positive. See, if it is positive, it will become plus infinity. That should not happen. If it is negative, it will become minus infinity. Again, that should not happen. This should not be plus infinity, should not be positive and should not be negative. This numerator should not be positive, should not be negative, means the only thing that it can be is 0, right? So we should have limit x tends to 1, f of x minus 2 is equal to 0. So this is equal to 0 means limit x tends to 1, f of x is equal to 2. Limit x tends to 1, f of x equal to 2, second option. Okay. Let's look at question 22. If x equal to 80 square and y is equal to 280, then dy by dx, d square y by dx square is equal. X is equal to 80 square they are given and y is equal to 280. Differentiate this with respect to t. Dx by dt is equal to 280. Dy by dt is equal to 2a. Then dy by dx is equal to dy by dt divided by dx by dt. That means 2a divided by 2at. That's equal to 1 by t. So we got dy by dx is equal to 1 by t. But we want d square y by dx square. Again you differentiate this with respect to t. D square y by dx square is equal to derivative of 1 by t is minus 1 by t square into dt by dx. Mind you, you are differentiating with respect to x. You don't just write minus 1 by t square. That also not there. Okay. So into dt by dx, right? So minus 1 by t square into dt by dx. So dt by dx is the reciprocal of dx by dt. dx by dt is 280. So dt by dx will become 1 by 280. So this is equal to minus 1 by 280. minus 1 by 2at cube, which is the fourth option. Next, 23rd question. If y is equal to log of 1 plus x by 1 minus x whole power 1 by 4 minus 1 by 2 tan inverse x, then dy by dx is equal to y is equal to, observe here, log m power n. Log m power n can be written as n log m. So I can write it as 1 by 4 log 1 plus x by 1 minus x minus 1 by 2 tan inverse x. Before I differentiate it, let us further simplify it. Y is equal to 1 by 4. This is of the form log m by n. Log m by n can be written as log m minus log m. So 1 by 4 log 1 plus x minus 1 by 4 log 1 minus x minus 1 by 2 tan inverse x. This is y. Now we shall differentiate this. Y dash is equal to 1 by 4 into derivative of log 1 plus x, that is 1 by 1 plus x, minus 1 by 4 into derivative of log 1 by x is 1 minus x is 1 by 1 minus x into minus 1. So I will write this as plus. Minus 1 by 2 into derivative of tan inverse x, which is 1 by 1 plus x square. Okay. I will take 1 by 4 as a common factor between these two. 1 by 1 plus x plus 1 by 1 minus x minus 1 by 2 into 1 by 1 plus x square. Take LCM here, 1 plus x into 1 minus x, that will give you 1 minus x square. This numerator will become 1 minus x plus 1 plus x minus 1 by 2 into 1 by 1 plus x square. Okay, here x gets cancelled, 1 plus 1 is 2, 2 gets cancelled, here 1 by 2 will remain. I will take 1 by 2 as common, then we are left with 1 by 1 minus x square minus 1 by 1 plus x square. This 1 by 2 I have taken common. Now take LCM. LCM is 1 minus x square into 1 plus x square, that's equal to 1 minus x power 4. Numerator will become 1 plus x square, denominator will become 1 plus x square minus of 1 minus x square, that will become minus 1 plus x square. 1 gets cancelled, x square plus x square is 2x square, 2 gets cancelled, that will give you x square divided by 1 minus x power 4, x square by 1 minus x power 4, which is the second option. 24th question. If y is equal to x power n, then the ratio of the relative error in y and x are ratio of the relative error in y and relative error in x. Relative error in y is given by dy by y and relative error in x is given by dx by x. We are asked to find the ratio of this. Okay. So we have y is equal to x power n. Let us take log here. Taking log on both sides will give you log y is equal to n log x. Log x power n, which will give you n log x. Now differentiate this. We get 1 by y into dy is equal to n into 1 by x into dx. So dy by y divided by dx by x. Bring it this side, that is equal to n. So relative error in y divided by the relative error in x is equal to n. N can be written as n by 1. So the ratio is n is to 1. Then if the curves y square equal to 4ax and xy is equal to c square cut orthogonally, then c power 4 is equal to 32 a power 4. If you can remember, directly remember that answer and then write it. If not, I will tell you how to solve it. Okay. Y square is equal to 4ax. They cut each other orthogonally. They cut each other orthogonally means angle between them is 90 degree, which means the angle between their tangents is 90 degree. When the angle between their tangents is 90 degree, m1 into m2 is equal to minus 1, where m1 is the slope of the first tangent and m2 is the slope of the second tangent. So differentiate this. 2y dash is equal to 4a. So y dash is equal to 2a by y. 2 gets cancelled. I'll call this as m1. Then take the second term. Second term is xy is equal to c square. Differentiate this. X into y dash plus y is equal to 0. So y dash is equal to minus y by x. Treat this as m2. m1, m2, since they intersect orthogonally, product of their slopes must be equal to minus 2a by y into minus y by x is equal to minus. Y gets cancelled, minus gets cancelled. We get x equal to 2a. X equal to 2a, I will substitute here. We get y square is equal to 4a into 2a, that will give you 8a square. Y square is equal to 8a square. Given xy is equal to c square, we want a c power 4, right? So square this equation. If I square it, I am getting x square, y square is equal to c power 4. X is equal to 2a, so x square is 4a square. And y square is 8a square is equal to c power 4. So c power 4 is equal to multiply this, we get 32a power 4. Then 26th question. F of x is equal to x power x has a stationary point at. Stationary point means what? Stationary point means the point where the function is neither increasing nor decreasing. In other words, it is stationary, which means at that point either the function is not differentiable at that point or the derivative is 0 at that point. So f of x, or I call it as y is equal to x power x. Derivative should be 0 at this point. Differentiate it. Y dash is equal to x power x into 1 plus log x. Did you understand? How did I get it done? So by taking log, if you want, take log y is equal to x log x. Differentiate 1 by y into y dash is equal to x into 1 by x plus log x. So y dash is equal to x gets cancelled. Y into 1 plus log x. So y dash is equal to y is x power x into 1 plus log x. If you can remember this. Y is equal to x power x means y dash is equal to x power x into 1 plus log x. Okay, when f is stationary, its derivative must be equal to 0. Either this is 0, this is 0, this cannot be 0. So 1 plus log x is equal to 0. So you get log x is equal to minus 1, x is equal to e to the power minus 1. E to the power minus 1, that's nothing but 1 by e. Okay, 27th question. Integral of 1 minus sin x by 1 plus sin x dx is equal to 1 minus sin x by 1 plus sin x. I will multiply and divide by 1 minus sin x. Okay? When I multiply and divide by 1 minus sin x, numerator will be 1 minus sin x whole square. Denominator 1 plus sin x into 1 minus sin x. That will give you 1 minus sin square x. 1 minus sin square x is nothing but cos square x. 1 minus sin x whole square expanded by using a minus b whole square. We get 1 square, which is 1 plus sin square x minus 2 sin x. Divided by, in the denominator we have 1 minus cos square x, which is 1 minus sin square x, which is cos square x. Now split this. First term 1 by cos square x, I can write that as secant square x. Second term is sin square x by cos square x, that will become tan square x. And here sin x by cos square x, I'll write it as cos x into cos x. Sin x by cos x becomes tan x, then 1 by cos x will become secant x. So together it will become minus 2 secant x tan x. Okay. So then further, before I integrate it, I'll write tan square x as secant square x minus 1. Already we have secant square x, so together it becomes 2 secant square x. Integral of 2 secant square x minus 1 minus 2 secant x tan x into dx. Okay, now you integrate it. Integral of secant square x is tan x, so 2 tan x minus integral of 1 is x minus 2 into integral of secant x tan x is secant x plus c. So 2 tan x minus 2 secant x, which is the first option. Okay. 28th question. Integral of 10 into x power 9 plus 10 power x into log 10 divided by 10 power x plus x power 10. Observe carefully. This is of the form f dash of x by f of x. If I differentiate this denominator, derivative of 10 power x is 10 power x into log 10 plus the derivative of x power 10 is 10 into x power 9. So this is of the form f dash of x by f of x. Integral of f dash of x by f of x is equal to log f of x. Log f of x means first option. Then integral of tan bar 10x plus tan bar 12x. You know this formula. Integral of tan bar mx plus tan power n minus 2x dx is equal to tan power n minus 1x by n minus 1 plus c. Remember this formula. If you know that, whether I could, as I think some of you don't know, or should I say most of you don't know, then what we can do? We can take tan power 10x as common. Then what will remain? 1 plus tan square x. Okay? Tan power 10x plus tan power 12x. I take tan power 10x as common. Then you have tan power 10x into 1 plus tan square x. 1 plus tan square x is nothing but secant square x. So tan power 10x into secant square x dx will give you f of x to the power n into f dash of x dx. F of x to the power n plus 1 by n plus 1. That will give you tan power 11x by 11 plus c. Third option. Question 30. Integral of dx by a square sin square x plus b square cos square x. Remember this formula? Remember this is the formula. 1 by ab tan inverse of a sin x by b cos x. 1 by ab tan inverse of a sin x by b cos x. Which can be written as a by b tan x. Third option is the answer. Okay, 31st question. Integral 0 to pi by 2 1 by 1 plus 4th root of tan x dx. I'll write tan x as sin x by cos x. So, integral 0 to pi by 2 1 by 1 plus 4th root of sin x divided by 4th root of cos x into dx. That's equal to integral 0 to pi by 2. Take LCM here. 4th root of cos x is the LCM. We go up 1. 4th root of cos x divided by 4th root of cos x plus 4th root of sin x into dx. Cos x, sin x. Integral from 0 to pi by 2. You know the formula. This is equal to pi by 4. Okay, with this I will stop this class. I'll continue the other questions in the next video.